Relativity means that you only know things compared to other things. That's the essence of relativity. You can't know something as if you were just an impartial, objective observer looking down upon the cosmos from God's point of view, so to speak. That is not our position as humans here on Earth. We are intimately involved with the process of understanding the world. We are not unbiased, objective observers. Even when we're being scientific, even when we're being mathematical and hyperlogical, we're still participating in this whole process of understanding things, of making sense of our life. And we do this process of making sense of life by comparing different parts of life to other parts of life. And this is how we get a handle on what life is. And this is relativity. So here are some basic examples of relativity. An elephant is large relative to a mouse. How do you know what large and small are, other than through comparing different parts of reality to each other? See, that's how you did it. When you were born, you didn't know what small and large were. You learned that through experience by comparing different parts of reality. Now, of course, this seems so obvious, but you don't overlook the obvious. It's in the obvious where we really get tricked. This stuff is not obvious at all. It's easy to accept for most people that, yeah, Leo, I understand that an elephant is large only relative to a mouse, and that actually it's tiny relative to the entire planet. That's so obvious. But just notice that as much as you might hate relativism, you will admit to this basic example. So you're already a relativist. It's just a question of where do you draw the line? And what I'm going to show you here as we keep going is that the line itself that you draw is relative. So where you draw the line depends upon you, depends upon your worldview, depends upon your experiences and your beliefs. And that actually there is no such line within reality. Some more examples for you. A triangle, as we know from geometry class, adds up to 180 degrees if you add up all three angles. But this is only relatively true if we are talking about geometry done on a flat plane, which is Euclidean standard geometry, the kind you learned in high school. But then there are other kinds of geometries. If you do geometry on a curved surface, depending on how it curves, the triangle will not add up to 180 degrees. See? So we have to admit of relativism within geometry. Or even, let's take an even more basic example. You take a look at a glass that's exactly 50% full, but at the same time, it's also 50% empty. So which is it? Well, it's both, of course. In fact, to say that a glass is half full or half empty is actually identical. But also, at the same time, it's not quite identical because it gives you a different flavor, a different interpretation. It means something different in your mind, whether you think of your bank account, for example, as being half full or half empty. It'll give you different emotions. It'll give you different motivations about what you should do about that. See? And notice what's interesting about relativism is that it opens us up to the possibility that what we might call the quote-unquote facts of the situation don't have to change for our perspective on it to change significantly. So how the facts affect us, how the world affects us, may not so much depend upon what the world factually is, but rather upon how you look at it, what perspective you take. The Eiffel Tower is 1,063 feet tall. But this is not absolutely true. This is a relative truth, depending upon the velocity at which you're moving at when you're looking at the Eiffel Tower. So one thing that Einstein showed is that actually the length of physical objects will change depending on how fast you're moving. And if you're moving close to the speed of light as you're approaching an object, let's say you're flying towards the Eiffel Tower, straight from the top, like from outer space, down, and the tower is standing like this, and you're flying down towards it, but of course you're very far away, and maybe you're looking at it through a telescope or some binoculars. Then actually what you'll see is that the length of the tower will change and be different. And so literally, according to Einstein, the tower does not have a fixed length. There is no way that the Eiffel Tower is. It only is how it looks to you given your frame of reference that you're moving at, given your velocity and given your relative position to the tower, of course, given the tower's velocity relative to you. That's a very twisted, relativistic, counterintuitive notion, which we'll be talking more about as we keep going here. That's general relativity in a nutshell. Another example is with science. Is science true? Many people today would say, yes, Leo, science is true. It's proven. But not so simple, you see. Science is true relative to what? It's relative to the past. 21st century science appears true. It's more true than 15th century science. That's correct. But today's science is going to look so faulty and wrong 1,000 years from now, in the 30th century. See? So this is very important to keep in mind, because otherwise you fall into the trap of thinking that science is just true all the time. No, science is not true all the time. Science has many inaccuracies and errors in it, as we know from the past, if you've studied the history of science. Science has gotten reality very wrong in the past. And more so, science is still getting reality very wrong today. It's just that it's very hard for us to see because we're sort of on the bleeding edge of the future. It's hard for us to see where science is misunderstanding reality. Because if we knew where it was misunderstanding reality, then we would have advanced science by a whole generation. But of course, that is what science is doing, is it's advancing itself every single day. But it does so slowly, it creeps along. So you can't tell where science will go 1,000 years from now. Or at least most people can't. Some of us can. So in this sense, science is very relativistic. And also it's relativistic in the sense that science is not the only way to study and understand the world. There are other methods which are different from science and sometimes even superior to science. A lot of people are not even aware of this possibility. They think science is the only way. They think science has a monopoly on truth, which of course it doesn't. So these are just some basic examples to start to get you to understand what we mean by relativity. Of course, you can look around you in the world and you can see thousands of examples of relativity. For example, even when you just like go to a restaurant and you sit down with your family, some members of your family will enjoy the food. Other members of the family will hate the food. It's the exact same food. So what changed? Well, of course, individual tastes, how people perceive it changes. And so that's what makes reality actually so interesting, is that there's so many different points of view and perspectives that we can take on it. It's so relativistic that it really stretches credulity. A lot of people, they deny this relativism by saying that, oh, well, those people are just wrong, they're just stupid, they're just crazy, or they're just ignorant. But that itself actually is the ignorant and the deluded position. So what you really need to do to start to understand relativism is you need to open your mind and really be willing to give credence to other people's points of view, such that you don't dismiss them too quickly. Otherwise, what happens is you become an absolutist and you think that your position is the only right one and that all other people are just deluded. And of course, this is how you create a sense of reality.